at Radix Sort, right? So Radix Sort is applicable where Radix Sort basically means that we are sorting on individual positions, right? Let us say I am given these numbers. So I am given 543, let us say 409, 625, 486. Then let's say I am given 518 and I am given 590. So let us say these elements are given, right? So I have just written them vertically instead of writing them horizontally, but these elements are given in an array and I want to sort them, right? One unique thing about these elements is that all the elements are 3-digit numbers, right? And that is given. So all the elements, number of digits in all the elements are same. So what we do is that first we sort on units place, right? So if I sort all these elements on units place, then what will come first? 590 will come first because 0 is the minimum element, right? Then 543 will come, then 625 will come, after that 486 will come, then 518 will come, and then 409 will come, right?
Yes.
So I have applied normal sorting algorithm to sort the elements on their ones position, on their least significant digit position, right?
Yes.
Then I apply another sorting, I apply the same sorting algorithm to sort the array on tens position, right? So I am sorting all the elements, but while sorting I am only considering the element at tens position, right?
Yes.
So if I sort the array on tens position, then this will be 409. So after 409, it will come out to be what? 518?
18, 625,
625, 543, then
486 and 590.
486 and 590. And after doing this, we will sort on the tens place, right? So after doing this, we will finally sort on the hundreds place. So now if I sort on hundreds place, so this 4 and this 4 are same, right?
Yes.
So I should be using a stable sorting algorithm. If I use an unstable sorting algorithm, then it will actually, I will not get, it will actually remove the previous sorting that I have done on all other positions, right?
Yes.
So having a stable sorting algorithm, using a stable sorting algorithm in this case is required condition, right? In most of the situations it is not a required condition, but in this case it is a required condition.
Yes.
Right? So first is 409, then I have 486, then this one and this one are 5. So I'll have 518, 543 and 590, and finally I have 625. Right?
Yes.
So which sorting algorithm should I use inside this Radix sort?
So basically, actually, it is random. So we cannot. Okay. We can use the counting sort here because we are given that since we are only sorting one position, basically units position, then we have the range from 0 to 10.
Right.
And
from 0 to 9.
And it can be any numbers.
Right. So we are given a huge number. We are given a huge set of numbers, but all the numbers are between 0 to 9.
Yes.
Right. So counting sort actually fits in this case. So counting sort takes on the order of n time, and because we have 3 digits, so we will apply counting sort 3 times. So it is going to take on the order of 3 into n, which is again on the order of n. Right. So in linear time we are able to sort it. Right.
Yes.
So in linear time we are able to sort it. On the other hand, if I apply quick sort, then it will take 3 into n log n time, 3 into order of n log n time, right? Right?
Yes.
So that will be worse than applying quick sort on the entire range. Right?
Yeah.
Right. So the most important thing is in the Radix sort algorithm is the supplementary algorithm that we are using. Right. Radix sort is not sorting on its own. Radix sort is providing an approach to sort using some other sorting algorithm. Right. But it is allowing us to use a linear time algorithm, which is counting sort, to sort the array on which that counting sort is not applicable otherwise. Right?
Yes.
And this is very useful in the sense that, let us say I have a bank and I want to sort the record of all my account holders in the bank based on their account numbers. Right? Now if you look at account number, then account number is a 10-digit number or maybe 12-digit number. Right?
Yes.
So for all the people who are holding account in this bank, the account number is going to be 10-digit or 12-digit number, whatever it is, right? So it is going to be the same. It's same in the sense number of digits are going to be the same, right?
Yes.
So radix sort is applicable. Let us say government want to sort or sort the record of all the citizens in the country based on their Aadhaar card number, right?
Yes.
Now Aadhaar card is again a number. Right? And number of digits in Aadhaar card is going to be the same for all the citizens. Right?
Yeah.
So what we are dealing with is 125 crore people, 125 crore records we can sort in linear time. Right?
Yeah.
Similarly, let us say we want to sort on PAN card. So PAN card is an alphanumeric number. So alphanumeric number means the range will be 10 plus 26. Right?
Yes.
So 10 plus 26, which is that we have 36 unique elements because because we do not have small digit numbers in PAN card, right? So even if we have smaller digit numbers, the range will be 10 plus 26 plus 26. If we are considering the smaller alphabets different from capital case alphabets.
Yeah.
Right? So radix sort is very useful in a lot of situations. Right? You can have companies whose employee IDs are of same digits for all the employees. So in those cases also radix sort can be used.
Yes.
Right?
Yeah.
All right, great. Any questions before we move forward?
No.